All right, hello math students. Today we're doing 8.5 functions with parabolas. So basically now we're gonna look at a parabola in the geometric definition, right? Geometric definition. So there are two terms we need. We need focus and we need directrix. If you have my lesson notes open, you'll look at the definitions. But focus is, so we know that the focus is, please refer to my lesson notes for the exact definitions, but what I really want us to know for this sense is, for the geometric definition, is every point on parabola is equidistant from directrix and focus. So you could tell by looking at this, a focus is a point and a directrix is a line. So we also are shifting our equation. So we're going to have y equals 1 over 4p times x minus h squared plus k. So it's the same as vertex, except, this is vertex form, except 1 over 4p is our a value. But it's very important because p is the distance from vertex to focus. Now, technically, it's also the distance from vertex to directrix. The reason why I say to focus is because if I go up, so say this is the focus and this is the vertex, up, then p is greater than 0. If this is my vertex and here's the focus, so I have to go down, that means p is less than 0. So I always say vertex to focus, so I know if it's p is positive or negative. So what they want us to do is graph and find the equations. Well, I know the vertex also has the same x value as the focus because it has to be the same distance. And then I know that the y value is the midpoint, so vertex x is the same as focus, and y is midpoint of directrix to focus. It has to be the same distance, right? Equidistance. So really, the y value of the vertex is going to equal -4 plus -2 divided by 2. -6 divided by 2, which is -3. So my vertex is going to be -3. So what I need to do now is find this p. So I know that my focus, let's just draw x and y. I'll draw y up here. And let's say we count by 1, 2, 3, 4, 6, 7, 8. -1, -2, -3, -4, -5, -6. 1, 2, 3, 4. 5, 6, -1, -2, -3, -4, -5, -6. So I know y equals -4 is my directrix. Sorry, I'll draw that in red. I'll leave my directrix in red. I'll put my focus in blue. So 2, -2 is my focus. And then I'll graph in black. So that has to be my vertex. P, I go up, so P is going to be 1. Again, I have my general form of my equation up here. So that means that P is 1, 4 times 1 is 4. So Y is going to equal 1 over 4 times x minus 2 squared plus 3. Hey, look, my vertex is at 2, -3. Okay, if I want to find other coordinates, right, I can just plug it in. Or 2, 2, I know this has to be a coordinate here at 4, -2, and therefore 1, 2, 0, -2, because both of those are, if I look at this green line, that's 2, that's 2, that's 2, and that's 2. That's the same distance, right? Also, if you plug in 4, 4 minus 2 is 2, 2 squared is 4, 4 divided by 4 is 1, 1. Sorry. That's my mistake. -3. Oops, let's see black. 4 minus 2 is 2. 2 squared is 4. 1 minus 3 is negative 2. Same with 0. So let's think of another one. Let's go 6. 6 minus 2 is 4. 4 squared is 16. 16 divided by 4 is 4. 4 minus 3 is 1. So 6, 1, 2 away, so negative 2, 1, because negative 2, same thing, right? So my parabola looks something like that. So again, very similar to what we did first semester, graphing parabolas, but now we're using this geometric term. Basically, the only difference is we're still using vertex form, but now we have to find that P, where A is 1 over 4P, and P is that distance from focus to vertex. So now let's look at number 2. Again, I'll do my directrix in red, my focus in blue. So I'm going to draw an XY coordinate grid. First of all, let's do the vertex first. I know the vertex has to be negative 1 because I'm his focus. 0 plus 2 divided by 2 is 1. So 1, 1 is my vertex. I see, so negative 1, 1, y equals 2. Ooh, it's an up and down. So I'll put my x-axis there. So my focus, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, negative 2, negative 4, negative 6. I'm just counting by ones. I'm just numbering every other, right? So my directrix in red, y equals 2. My focus in blue, negative 1, 0. So my vertex has to be negative 1, 1. Halfway in between, 1, 1. I know I'm opening down because P is going to be going down 1, negative 1, because 1 plus P equals 0, so P has to be negative 1. Right? My 1 is my vertex, 0 is the focus, so I open down. Again, we go vertex to focus, okay? So my P is negative 1, that means my equation is going to be 1 over 4 times negative 1, so negative 1/4 of x plus 1 squared plus 1. So I know I'm opening down, right? So let's plug in. So again, 2 away, 2 away, 2 away, 2 away, right? My green line tells me this is 2, and that's 2. And by definition of directrix and focus, every single point is equidistant. So 2 away, let's go 3. 3 plus 1 is 4. 16 divided by negative 4, negative 4. Negative 4 plus 1 is negative 3. So 3, negative 3, and therefore negative 5, negative 3, because our symmetry still exists. We still have that access to symmetry on parabolas. So everything we learned about parabolas in first semester applies here. All right. And there you have it. So let's continue going with 3 and 4. So again, it's been since we've been working with this, I always want to make sure I know the general form of our equation. So y is going to be 1/4 x minus h squared plus k. And we might, I'm not talking about it yet, but you could flip it, but we're not going to talk about that yet. So let's first find the vertex. I know my x-coordinate is 1 because the focus has a 1 in it, the x. Okay. So, and then the y value is the midpoint. So 3 plus 7 divided by 2, 10 divided by 2, which is 5. So 1, 5 is my vertex. So if my focus is 1, 7, my vertex is 1, 5, directrix to 3, I know I'm going to open up just by logic there. So there's my y. I'll put my x down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 2. My directrix is y equals 3. and my focus is at 1, 7, and my vertex is at 1, 5. So this time, I'm going to go 1, 2, 3, 4, and 4 to get a coordinate there. I know I did this before I found the P, but 1, 2, 3, 4, 1, 2, 3, 4 to find another coordinate there. Sorry. My P value, so I know that 5 plus P has to equal 7, so P is going to be 2. So it's going to be y equals 1 over 4 times 2, or 1/8, times, oh sorry, there's a P there, x minus 1 squared plus 5. Okay, and let's double check that. Let's say I plugged in 5, 4 squared, 16, divided by 8 is 2, 2 plus 5 is 7. Okay, let's try, that was 1, 2, 3, 4. So that was at 5, 4 over would be 9. 9 minus 1 is 8. 8 squared is 64. 64 divided by 8 is 8. 8 plus 5 is 13. So what was that? 9, 13. And if it's 9, 13, then 4 over from negative 3, negative 4, negative 5, negative 6, negative 7, 13, because symmetry exists. And my parabola looks like that. So I don't know if you've decided if this geometric version is easier than all the algebra stuff you're doing first semester. But to me, looks like a little slightly easier if I'm given whole numbers for directrix and focus. So last one of the graphing. Directrix y equals 3, focus 2. So I know I have the vertex of 2, comma, my y value is 3 plus negative 1 divided by 2, 2 divided by 2, 1. My p value, I know that I have to go to 1 to negative 1. So I know that 1 plus p equals negative 1. So p has to be negative 2. So my equation is y equals negative 1/8. Negative 2 times 4 is negative 8. Times x minus 2 squared plus 1. All right, so let's draw my grid. It's going to open down because the negative in front. Y equals 3, then down. So I'm just put my y in the middle. I'll make my x slightly higher than the middle, just so we can see the directrix. 1, 2, 3, 4, 5, 6. 2, 4, 6, 8. Negative 2, negative 4, negative 6, negative 8. Negative 2, negative 4, negative 6, negative 8, negative 10. So my directrix is at y equals 3. And my focus is at 2, negative 1. So my vertex was at 2, 1. Okay, now I'll do my whole 4 points away. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Again, directrix and focus both have to be the same distance away from every single coordinate. Can I do a 2, 8, 8 minus 2, 6, 6. So I could do 10 technically, 8, negative 64, or negative 8 plus 1, negative 7. So 10, negative 7 might be somewhere right here. And then that's 1, 2, 3, 4, 1, 2, 3, 4. Negative 7 is somewhere right there. If I was really on top of it, I would have graphed it slightly more to the right, but here we are, and that still looks like a parabola to me. All right, so that's how we graph these in directric focus form. And now we'll go into some generalization. So we graphed 4 of them, and now we're going to generalization. So given the focus and directrix, how can we find the vertex? Well, the vertex x value, same as focus. And then the y value is midpoint of y values of directrix and focus, right? So if my focus was A comma B and my directrix is y equals c, then the vertex is A comma B plus C divided by 2. So the average of the y values of the directrix and the same A value as the focus. Given the focus and directrix, how can you tell the parabola opens up or down? So if focus is below directrix, we open down. If focus is above directrix, we open up. So if I have a coordinate grid, right, I'll go back to my directrix being red, my focus being blue. Then I know my parabola has to go between the two and open down, right? Focus below directrix. Now on the opposite, when I have a directrix and the focus is above the directrix, then I know my parabola has to be between the two, so it opens up. Okay, so focus above, focus below. How do you see the distance between the focus and the vertex in the equation? Well, P is the distance between vertex to focus. So if this is my parabola, there's my vertex, there's the focus, then this is P. In this case, P is greater than 0. If my parabola opens down, there's my vertex, there's my focus, there's my P. In this case, P is less than 0. So describe for writing the equation. So first we use y equals 1 over 4p times x minus h squared plus k. Find hk, which we know by now is our vertex. And then find p, which is C7. And then plug in p and hk to the equation. All right, so that is my lesson on our parabolas in focused directrix form. I did skip to 8.5 because I felt like we didn't need to do as much with 8.4 as I initially thought, because I believe you all have backgrounds with working with quadratics. All right, thank you for watching or listening to this lesson video.